I guess we can't hear him because he's recording.
All right, well, let me introduce Greg, and Greg is a top network engineer. He's going to tell us why domain name systems is a great thing to have.
So I'm going to talk about DNS today, the domain naming system. I just wanted to quickly say that this is a two-part presentation. I'm talking about DNS, sort of more of the basics, and there's going to be next month, we're going to have a second presentation. Craig's going to conduct that one and taking a slightly more of a deep dive into DNS. So hopefully everybody can attend that one as well. So let's start off with looking at what is DNS. I kind of pulled out 3 different definitions that I thought were useful. One is just talking about DNS as a naming hierarchy for the internet. I'm not going to describe this one in too much detail here because we're going to see it multiple times throughout this discussion, but just keep that in mind that hierarchy is a big part of what DNS is all about. DNS is a service for looking up internet resource records. So the very typical scenario is taking a domain name, like on the side here, you can see www.google.com, going to the magical DNS black box, and then it resolving and returning back an IP address. Of course, our computers or tablets or phones, they all really don't work on IP addresses. They don't work on these domain names, which are there for the humans, the IP addresses for the computers. Another way to look at DNS, which is slightly more low level, is that it is a protocol, and it is a protocol that enables name resolution and generally resource record lookups. I'm not going to talk about it at this level because it's pretty, there's a lot of nitty-gritty there, but there are some RFCs that are out there, 1034 and 1035. So if you want to actually do more research and you're interested in that level, there's a lot more information out there for you. During this presentation, I will talk about 2 analogies. This one I'm calling my 10-second analogy, I guess. So you can think of DNS as a phone book for your network. So with a phone book, we have people's names. We will look through the phone book and find that their names can resolve to a home address and possibly a phone number. Similarly, you can have with your name, with a domain name with DNS, you can do a lookup and you can get back not a phone number, but an IP address. So you can think of DNS as kind of your phone book for your for the internet. Any questions about that? Let's keep on going. So DNS, why do we need it? It kind of comes down to abstraction. Domain names provide an abstraction over the internet protocol. So names are easy for human brains to understand. IP addresses are not as easy for us to understand and remember. And I decided to use an IPv6 example here. So say VicPiMakers.ca, that's a relatively easy thing for us to remember versus this wonderful IPv6 address 2607:7B000:3,000:4:597E:EBAD. That might be a little harder for you to actually remember if you had to type that into your browser. So you can see why we would go with something like VicPiMakers.ca and DNS to help us with lookups. People do tend to remember a lot of v4 addresses. I try to tell people, DNS has some value, especially once we start moving to these v6 addresses. I think you want to probably leverage that. So DNS also provides flexibility. So for example, IP addresses, they can change. So what that might represent is a server being migrated from maybe from one side to another. But on top of it, your, say, VicPiMakers.ca domain doesn't change. What will change? The DNS record and the IP address underneath. So you can maintain an abstraction through the domain name, and you don't have to really care that the IP address changes underneath. You can also have multiple IP addresses. So you may have different IP addresses that are geolocated and will resolve differently depending, say, if you're on Western Canada versus Eastern Canada. And so say in Google, I want to go to a site, they'll send me to an IP address that will route more closely for Google to where I am at versus if I was, say, on Eastern Canada. So that's another place where DNS is useful and provides an abstraction. I haven't seen this actually listed anywhere, but I was thinking also that it provides an abstraction just over the IP protocol version. So the VicPiMakers.ca example, again, could resolve to both v4 and v6. We don't really care, and the DNS handles that for us, and we'll make the browser aware, but from our perspective, we just maintain that abstraction. So DNS is valuable to us in all these ways. Any questions about that? Okay, I thought I should give some information also about the types of DNS records. I didn't actually realize when I was researching this presentation quite how many DNS record types there are out there. There are a lot. I haven't provided all of them because probably being comprehensive about the record types would take up the entire presentation. So if you want to do more research there's a lot of information out on the internet, and you can probably just use Google or whatever your favorite search engine is to find that. But I have listed some of the common ones here just to give you appreciation for what's out there. So we have A records. So an A record is where you will take a domain name, you will resolve a IPv4 address. There's quad A records for resolving IPv6 addresses. Why it's quad, I'm not exactly sure. I thought I might ask Craig at some point exactly why that is. I was trying to look for information. I couldn't find it. Craig, do you happen to know?
It's an internet joke.
Okay.
So since an A record represents a 32-bit address, 4 A's must represent a 128-bit address.
Oh, I see, because it's 4 times the 32.
Right.
That's definitely a computer science joke. So there you go, quad A records for IPv6 addresses. There are also MX records. Those are mail exchange records. So for a particular domain, you may want to resolve to the mail servers, not say the web server. There's also name server or DNS servers that are authoritative for a domain. So you may want to actually get that back, and that's often part of your DNS request process. There's CNAME records or canonical records. Those are, you can think of them as aliases. So for example, something like facebook.com might also have an alias, something like www.facebook.com. And that www part may not actually be a separate server. It may just be a CNAME record that points to an A record that points to the IP address for Facebook, for example. There's also PTR records. I just put this in this for just point out that you can go the other way. So you can go from an IP address and you can point back to the host name. So not only can you go forward for IP, or sorry, domain name to IP, you can also go backward from IP to host name.
Could you go over that NS record again?
So the NS records, those are the name server records. So those would be, for example, there are authoritative name servers within your domain. So for example, say for Facebook, if we're talking about the Facebook example again, there would be a set of authoritative name servers for Facebook that actually is aware of all the IP addresses that Facebook that are under the Facebook domain. Does that make sense?
Well, isn't when I get a domain name and I declare who the where the servers are, the name servers are.
Well,
I think I put that. I have to put that in my record, but I don't know that is that an NS record that I'm creating at that point?
No, so and that's a really good question. So I think you're talking about, say, how you're configuring DNS.
Yeah.
This is where the hierarchy kind of comes in. So we're going to go through that and a few different times. So just hold your question, and at the end, if you're still a little confused about it, then we should probably I should resolve at that point. But I think you'll probably get it as we go through the presentation. Any other questions? Okay. I decided this time to go with a different tool. So if you have your laptop handy and you want to follow along with the lab exercises, we kind of have a tradition of trying to do a little bit of lab. It's a little harder with the remote, but if you'd like to, I want to use Dig for all the exercises this time. Typically we've done Wireshark, but why don't we try Dig and see how people like that? So you can use on these different distributions, you can try to install the tools this way. If you have a Mac, you can use a brew install, I believe, to be able to install it as well. I'm not sure about, I think there is a version for Windows, but I don't know the details about that one. So maybe I'll just give everybody a minute. I'm just trying to figure out, maybe you'll come back here. And how would we do this?
You can install Ubuntu, at least the command line and the command terminal in Windows. So, for example, I just have Ubuntu 20, whatever it is, 2004 installed on Windows, and I just go to Bash and it gives me the terminal.
So
it worked for me.
Good.
On Ubuntu.
Okay.
Sudo app install DNS utils.
Yep, me too in Fedora.
Excellent. Anybody else having troubles?
I have Dig installed on my Mac, but I don't know if I put it there or if it came with it. I don't remember if I put it down there.
I give 10 seconds counting down. Not sure how to get the feedback on this one. We can put the hands up here, I guess.
Hands up if you got it, or hands up if you don't.
Hands up if you don't.
I
If
see
you tell me more
two.
time.
No, oh, you're sharing your screen. I see. It's like a mirror that goes on forever.
Looks like everybody's good then, because hands up if you're having problems, but I don't see anybody putting their hand up. So, okay, want to keep on going. So we're going to try this, just a little example, just to make sure everybody kind of has use of the tool. So we're going to try this. We're going to make a slightly more interesting, do a quad A record. So looking for a v6 address. So if you type in dig VicPiMakers.ca and then 4 A's afterwards, then let's take a look at the results there. And I will give that a go as well.
So is this a GUI thing, or is this do I run this in the terminal window?
Terminal. Sorry, yeah, that's definitely terminal. I'm a bit of a command line junkie, so
I was a little bit too slow. I didn't get all the. I only got as far as DNS. I have to install DNS on.
Oh, sorry. Maybe
Yeah,
what
okay.
I'll do.
Let me do the next two.
I'm just wondering if I can paste that in there for you. Maybe I'll paste this into the. How come it's not coming back up?
Well, I don't see sudo DNF. I don't see. So I guess that's.
No, I had some fun all of a sudden.
So Murray, you're running Ubuntu, right?
Yeah.
So you just do the top line. You don't do the other lines.
Oh, I get it. Okay, I understand.
So I typed DNS utils and I got command not found.
Right, because DNS utils is a package name, not a command name.
Okay.
So.
Oh, I typed dig.
Right, the command is dig.
dig. Take it away.
Try and put this in here. So here's the installation commands. And then Here's the command for looking up the quad A record. Oops. He's in the chat window in case you want to give him a try. It's kind of compressed it funny, but I can try here. Can you still see my terminal screen?
Yes.
Okay. So I'm just going to walk through this so everybody kind of understands what's going on. I'm not going to provide all the details because I don't frankly know all the details, but I do know some of them. So one of the main things that I look at when I'm looking at the dig results is just the status. So we definitely want to see that there's no error. That's an important thing to see. We can see that there's one query that I've issued. This is the quad A record request. You can see that there's one answer that's provided back. There's also an additional response provided, which I've seen different results with different dig tools. And for some reason, whenever there's just one, it doesn't actually show me the addition section. Some of these will show the additional section, but not this one. And I don't know exactly why that's the case. But the main thing here is that we want to see that we do get back one answer. Here's the answer section. You can see that I get answer for VicPiMakers.ca. It says in quad A, and it actually provides me back the V6 record. It also provides me with this value here, which is called TTL, or time to live. We're going to go through that in more detail in a bit. So everybody okay with that? Can we continue? Get this back.
Good so far.
For some reason, it doesn't want to present it properly anymore. Oh, there it goes. Interesting.
What's a status NX domain mean?
I don't know. We'd have to take a look at your screen.
Well, I just typed in a domain name for one which we let expire, and I just wondered what it would answer for that. So you want me to share that?
Yeah, why don't we share it and take a look at it? I wouldn't mind. Sure.
So I think I got the right name here. Let me share this here.
This is going to be an interesting challenge of how we deal with lab stuff while we're in group sessions. So this is a bit of an experiment.
Okay, so I'm pretty sure. Let me just check and make sure I got the right domain name here.
Is that your avspc.org?
Yeah, I'm just looking to see what this is. Hang on. So this site can't be reached anymore because we let it go by. avsbc.mn. Oh, that. But there was a name for it too, which was avsbc. Anyway, let me get off this. Back to.
Yeah, it's not responding back with the quad A record. That's the short of it.
Is that what it is?
Yeah, it's because there's something not quite right is essentially what it's telling you.
Okay.
Yeah. See that your answer is 0. Your query is 1, but your answer is 0.
Hang on, I've lost my my screen here.
Well,
Okay, carry on without me.
Okay.
I gotta find my way back.
And
I guess I stop sharing and then you'll be okay, right? There you go. I've stopped sharing.
so we did the quad A record. The next one I wanted to try is just this very similar query, but this one's going to be with a www in front of it, .vicpimakers.ca. So give this one a go, and then we can talk about it. I'll give everybody 30 seconds to give it a try. Hopefully it's already still in your buffer. So
where are we going? God, that.
did everybody get a chance to try that one?
Yeah.
But just putting the www in front of it, right?
Yeah, that's right. So
Same address.
yep.
Okay.
The thing that you want to observe with this one, again, you want to see that the status is no error. You can see that it's, again, just one query, but this time we get back 2 answers. So that's the interesting part. And why do you get back 2 answers? And this goes back to what I was talking about before, that www.vicpimakers.ca, the www part isn't actually a separate server. All it is a canonical record, or what you can think of as an alias. That alias points to VicPiMakers.ca. So that's all that gets handed back in the first answer. The second answer that gets handed back as well, you're actually asking for the quad A record. So VicPiMakers.ca, we get handed back in quad A, and then we get the v6 address again handed back. So you can see that this is basically how you can alias and create different domains or subdomains that resolve to basically the same IP address. Any questions about that? Here. Okay, let's keep on going.
And then I see my server is the address of my router.
Your server. Oh.
Yeah, your DNS server is your.
Oh, your DNS server. Yes. Yeah. Sorry. So my DNS server is
CrowdStrike or
Cloudflare.
There.
Oh, you know them already. So yeah, so this is we'll take a look at the DNS settings in a second. I was going to go through 2 configs. One I'm going to go through in a little more detail, which is this nsswitch.conf, and then the other one is etcresolve.conf, which I think Craig is going to talk more about in his presentation. So I'll just talk about that lightly in this one. So this etcnsswitch.conf that you have on your Linux box, it's essentially, you can think of it as a way to have an ordered list of data sources for name resolution. So if I go here on my command line and I grep for our hosts and etcnsswitch.conf, you can see that I have for hosts, and this is what it is for host lookups, it goes to files and then it goes to DNS. So this is actually an order list from left to right. So if I change these orders, then DNS will actually be the preferred first. But in this case, files is set first, which is kind of the typical scenario. What is files? Files is actually my, you see, hosts file. So whatever's in here, I can resolve with the files name resolution. Otherwise, it's going to go out to DNS and look for everything else. And you can see I put in a dummy entry here. So I find that this is an interesting thing, and I'm not exactly sure why Dig behaves this way. Sometimes Dig will actually I found this etc host entry, and sometimes it doesn't. I'm not exactly sure why. But I have found a more robust way of doing this. So I use this get entity a hosts, and then I can do whatever my dummy host entry is. And then you can see that it will actually find that entry that I've configured, and just to prove that it will actually go out to the internet, I'll try to do something a hosts, something like google.ca. You can see that it actually goes out and doesn't have the record there. So it's actually gone out to the internet, and I looked up both the v4 and v6 addresses in this case. So
is getEnt part of Git?
No, it's just it's
part of
it's part of the operating system's tool set.
Okay.
I think it's a standard part of the operating system tools, because I don't recall installing it myself. So, but it is a way that I found just as an easier way to look at if you're troubleshooting. The reason why I wanted to bring this up is if you happen to be troubleshooting and you're wondering why is this not resolving, you might want to take a look at the etcnsswitch.conf and make sure that is resolving. And you can then also observe this using the getEnt approach as well.
So
some
we
other
use that for putting a host on our LAN, right?
That's one way you could do it. Yeah, there's more. I'd say there's more than one way. There's also, if you have DNS, some people have a way to do DNS through their routers. So if you have that, then it's an option just to configure in your router, and that way all hosts can at least see the local information that way. I think that Craig, is this going to be part of your presentation? I know you're going to talk a bit about Soho setup. Is that part of your presentation as well?
Yeah, I'll be talking about how to do it on a router.
Okay, there you go. So there's going to be more to come in part 2. So I'm trying to get you motivated to attend our second session.
So I'm just saying that in a Windows environment, we used to have to set up our host file if we wanted a local on our even the same computer, a web server to be found. We'd have to put that entry in the hosts file, right?
Yep, it's a similar thing. So you would have to set this up in not in the host file. If you want to, and if you didn't have it in DNS, then you can put it in the host file, and you can still get name or a name to IP resolution that way.
Sort of. I mean, the host file only works for that host. So if you have two computers and you put a host file entry in one, the other computer won't know it.
That's good.
Yeah, I think I was only using the one computer.
Yep, then you're good.
Yeah.
This is not so much that this is the recommended way to do it. This is more just to make you aware, because I do know people get sometimes confused as to what's going on with their name resolution. So this is more of a troubleshooting. You may want to look at this config just to make sure that it's actually doing what you expect it to do. The other thing about etc/nsswitch.conf is that it actually helps to manage a number of other services. So you have typically resolving locally things like your passwords or your user database, your password database with Shadow, your groups, these sort of things. They also can be done using, if you take a look through /etc/nsswitch.conf, there's other ways to actually manage this as well. So you don't just have this sort of ordered data source resolution just for hosts. It's also for other services that are on your operating system. I noticed that they still reference things like NIS, so that's pretty big legacy network information service. I don't see that used very often, but so there are other ways that you can resolve these things anyways. Any questions about nsswitch.conf?
Yeah. Could you say that all again?
Which parts?
Well, I don't know where we got to this. I mean, I didn't run that. The last thing I ran was dig, I think, and wasn't it?
This part here, you did this.
Yeah.
And then we moved over to this slide here. So we're just talking about the DNS configurations at this point.
Okay. Oh, yeah, you're talking about grepping a host file. Okay.
Yeah, and that's all I did here on the command line.
Okay.
So when I went to the command line,
I'll stop drinking.
Heavily.
So yeah. So anyways, the only thing that I wanted to point out here is that this does influence your name resolution. So you probably should just be aware of it. Really, that's the only relevance to DNS in this case. The other file that is very relevant to your DNS configuration is the resolve.conf file. And I've only put in name server entries. There are a number of other line items that you can put into this. The name server entries are basically DNS servers that you can point to. So each one is a different name server. So for example, this one here, 1.1.1.1, this nifty IP is owned by Cloudflare. This one here is owned by Google. I think this one is an open DNS. So these are all public resolving name servers that are out there. So I just configured some of these for my examples today. This isn't typically how people get their name server configured. So this is a manual configuration. It is possible to do it that way, but most people will receive that through DHCP. So when you actually are getting your IP address information, also you will receive DNS information that way. And Craig is going to go over that in more detail in the next presentation. He's also going to talk about IPv6 and RAs, I believe, as well. So there's more to come on this, but the thing I wanted you to know here is that there are kind of two files that you should be aware of when it comes to DNS configuration. etc/nsswitch.conf, just for that ordered preference of your name service, and then etc/resolve.conf, which actually says which name servers you're using and has more detailed DNS configuration information. So Does that make sense? Any questions? Okay, moving on. So this is the kind of the meat of the presentation, is talking about the DNS hierarchy, really, and how you traverse through the DNS hierarchy to be able to get your name or your IP records. So so in this example, we're going, I've actually pulled these out of Cloudflare, so I'll give credit to Cloudflare. They have quite good documentation on DNS. So I've just used their picks to be able to help illustrate the sort of traversal that takes place in your browser, and it's all abstracted to you, but it's interesting to look at it when you're looking at the technology. So in this example, we have a laptop. The laptop, it wants to go to a website, and this website is going to be example.com. Of course, with just a domain name, we can't get to that website. We need an IP address. So of course, we reach out to DNS to get that information. So the first DNS server that we go to is called DNS Resolver. I've also heard it called a recursive name server or a recursor, and there may be other names for it, but it's typically the one that is configured in your etc resolve.conf file. Now you may have a pointed to your local router. That's often a setup at home. So if that's the case, then you're actually going through that and then out to the recursive name server. So here, we'll walk through this example. We're looking up example.conf example.com. We go out to the DNS resolver. The DNS resolver, if it has that record already cached, it will just hand back the IP address record, and then you can use that to query. You send an HTTP request, get back an HTTP response, and your browser can render that page for you. If we don't have the record cached in the recursive name server, then what will happen is your browser will communicate with the DNS resolver. The resolver said, I don't have that record. It's going to reach out to one of 13 root IPs that are out on the internet. The DNS resolver is aware of all the 13 IP addresses that are out there. We're going to talk more detail about these 13 IPs. So hold your questions on that one. And those 13 IPs resolve to what's called a root domain name server. That root domain name server is aware of all the top level domains. So the .ca, .com, all those name servers have their own separate name server, or all those top level domains have their own separate name servers. So what's going to happen is I'm going to go to the root name server. It's example.com. So the top level domain is .com. That's the only part that it cares about. That .com, for that .com top level domain, I'll get back a list of from this root server to the DNS resolver. It'll hand back a list of top level domain name servers. From there, my DNS resolver will pick one, and it will say, I'll go and talk to this top level domain, see if it has some more information about example.com. This top level domain name server, assuming it does have records, will say that it can return the authoritative name server for example.com. So this isn't the A record that it's returning, it's the NS record that it's returning. And it's typically a set of NS records. So it'll return back those name server records. The DNS resolver then says, okay, now I know where the name servers are. It goes to example.com name servers. Those name servers will then say, hey, I have the A records for that. Here you go, hand back. It's as the authoritative name server, hand back the record to the DNS resolver. The DNS resolver then will say, hey, I have the record finally, and say, I don't want to do that again anytime soon. So it'll cache the record, and then it'll hand that back to your laptop. The laptop will then go out and make the query, get back the HTTP response, and render the page. That's a lot of information to take in all at once. We're going to go through this again slowly. So that's a high level, but we will go through it again in a little more detail and a little slower. So if you have questions about this, why don't we hold them? And once we go through, we're going to step through each one of these, and then you can ask your questions if it's still not clear on the next cut through. So here, so I was talking about, I have my sort of 10 minutes analogy versus my 10-second analogy. So this is my 10-minute analogy. I'm going to say is that DNS is like a library, and you can think of your recursive name server or your resolver as your friendly librarian, and he or she takes your request, in this case in the library, for a book, and can return back a result. That in this case, the first thing that the library does when you come in and make the request is that she's going to say, hey, I have this stack of books that people are popular and people have been taking out. You can think of those stack of books as basically the cached records that are held by the resolver. So the resolver will hand back a record immediately if it has it. So like the librarian will hand back the book immediately. The resolver will hand back the record immediately if it has it in its cache. If not, then it's a very friendly librarian, and your recursive name server is very friendly. What it will do is actually traverse the entire library system for you to be able to get back the record. Maybe this isn't your actual experience in a library, but we're going to pretend that we have very friendly librarians doing this work for us. So where are these recursive name servers located in our networks? So at most, pretty much all ISPs like TELUS or SHA or whoever will have their own set of recursive name servers that they'll have in their network that you can use to perform this level of the DNS sort of system for you. Enterprises will also have their own internal recursive name servers. And you can also go to public DNS. And so I have in if I take a look here, oops, see here that I actually have these two name servers configured in my etcresolve.com. So I'm actually pointing to Cloudflare's public resolver and Google's public resolver in my for my DNS for these exercises. If you you don't have to, like, the recursive name server doesn't have to cache. It's not a mandatory that it does caching, but you typically will get that. It just makes more sense because if you were to continue to go through that hierarchy, it just slows down your search results. So you would rather just be able to hand back the records straight if you can. So that's why caching is a good thing in this case. And we're going to talk about TTL, which is, again, the time to live. The time to live is an important part of what the DNS resolver needs for being able to manage those cached records. Any questions about that? That is the recursive name server. No? Okay. That was a lot of talking, so we're going to move out to another dig example. This one, I've put this, you may or may not have this watch command. It's not really important if you have this. You can also do it by just doing a dig VicPiMakers.ca and looking, I put in an A record this time. If you want, you can do this grep as well, but really what I'm trying to get you to look at is just this part here, and observe when you're looking at this record in the answer section and seeing what happens with this value. So that's that was my goal with this. So if you want to give that a try and just tell me what you observe with a TTL. I give 30 seconds and I'll see if anybody wants to come back with the answer.
You took away what we were to type, but I guess you're going to show it here.
Yeah, sorry. I will. Why don't I do it this way? It's hard to go back and forth. A better way to do this. How come you're not going back now? Come on, Google, help me out. Yeah, I'm gonna have to. Oh, I know what I can do. This grep -a. Oh, did I get it wrong? Answer section. got it wrong. Doing something wrong here. I need to copy and paste to VicPiMakers.ca.
You forgot the one in front of
Yeah, you need the A1.
Oh, thank you. There we go. So this is what I wanted you to see. So can you, I don't know if it's, can I make this bigger? Not able to make it bigger. Can you see all this is ticking down, this value?
Yep.
Okay. So that's all I really wanted to show you. You know, if
Hold it there for a sec. I don't want to VicPiMakers.ca, capital A, pipe to grep, -A1. So I'm not seeing anything like that. I get a prompt at the end of it.
I'll put it in here just to make sure that, so I'm putting it in the chat window, and you're saying you get a prompt at the end?
Yeah, I'll show you. See it? So here.
You forgot to close the single quote.
Yep.
Yeah, that's
Nice.
not a prompt. That's a
I see.
special prompt to tell you that you need more.
So where did I do that wrong? Okay, I'll stop sharing.
Okay.
Yeah, you just need a single quote at the end of that line, George.
At the end of the whole line?
Yep.
So the thing I wanted you to observe there is just that you get this ticking down, and that's the TTL value. And that's basically every time you query that recursive name server, it's ticking down that TTL. And at some point, that's going to reach 0. And when it does, it's going to go through the whole hierarchy and search through to get back to the authoritative name server and get back a result. And then it's going to cache that record, and then it'll start the ticking down again. So does that make sense to everyone?
Yeah, it's cool, Greg. I've never done a watch on that before. That's interesting to watch the countdown.
Yeah, I just was thinking, how can you illustrate that? So that I thought that might be a fun way to do it. But it is a bit of a mess of command line stuff, though.
Yep.
Oh, how come I'm not? Okay, so the next thing I wanted to talk about is root name servers. So you can think of the root name servers as kind of an index or like a card catalog in our library analogy. So the librarian is going out to the card catalog and doing a search. So this is where we get into, again, the hierarchy at the root with the root name server. We go out and we have these 13 IP addresses for those root domain name servers. And one of them we choose and we say, hey, could you give me back the top level domain names records for the, in this case, VicPiMakers.ca, the .ca top level domain. And so the root name server will hand back the next level of name servers, which is the top level domain servers. In this case, specifically the .ca. So say if it was a .com, there's a whole different set of .com root level, or sorry, .com top level domains name servers than there are for CA servers, for example. So there's a lot of name servers out there that are helping to manage all this infrastructure on the internet. I wanted to quickly show you this too, is that there is actually a listing of the root servers. I said there's 13 IP addresses, but if you take a look here, it actually says there's 1,086 instances out there on the internet. Which is interesting. So, and you may ask, well, how does that work? How do you get 13 IP addresses and 13 different, or 1,086 hosts out there on the internet? And that's done through the magic of Anycast IPs. And Anycast IPs apparently are enabled through the magic of BGP, which is the Border Gateway Protocol. This is kind of out of scope for the discussion, but it is an interesting topic. If anybody ever wants to go down into that level of detail and sort of understand how the Anycast and maybe even talk about BGP, that probably would be an interesting Netsig discussion for the future. But if I'll just leave that as a sort of pointer for now and say that if you're more interested in how this works, look up Anycast IPs and you can figure out more details there. Oh, this is the challenge with the lab, is trying to get back to where you were. Can you show me? I don't know why Google's giving me such a hard time with this one. Is it here? Here. Okay. So now we've gone past that root name servers. We moved to the top level domain name servers. The top level domain name servers now have more records beyond just the top level domain. They also have records for the larger domain. And specifically, they're the name server records. So you're at now this sort of second level in the hierarchy. Again, it's still from a library analogy, we're still basically looking through the index and trying to get to the final level, which is the authoritative name server. So this intermediate top level domain points to the authoritative name server for, in this case, in our example, VicPiMakers.ca. Again, there's lots of different top level domain name servers out there, and for all the different top level domains. So you have top level domains like .com, .edu, .net, .org. They will have all their own set of top level domain name servers. You also have country coded ones like .ca, .us, .uk. And then there's also new ones, these new generic ones that people that are being put out there for more e-commerce. So .beer, which big favorite of mine, .fyi, .wtf. So there's lots out there, and apparently you can get your own if for the small price of $200,000 US. So if you are interested in getting your own top level domain, it is possible to purchase one, and if you can make that a business model work, I'd like to hear more from you about it. So. Any questions about top-level domain name servers?
I have a question.
Mm-hmm.
Can you hear me?
Yep.
Oh, good. Okay. I'm sitting in my room in the basement. Never mind. Carry on.
Oh, you just wanted to know if I could hear you.
Yes.
Okay. The final level here is the authoritative name servers. So typically the final name server in the recursive query, assuming that you get that far. So in this case, so you can think of in the library analogy again, we've gotten out to the stacks. We're actually ready to find the book. The book is basically that final A record. So we get to the name server, and then we can say, okay, finally, we can ask for VicPiMakers.ca A record, and that will then hand back from the authoritative name server back to the recursive name server, the A record. And that now allows the recursive name server to cache that record through all that effort. So you can see that the librarian or the recursive name server does a lot for you in this to be able to get that record back into your browser's hands, so to speak. And just to give some respect to the various servers, so we can do a few more dig queries. I have this one for just name servers. This is just, I wanted to show you that there's more than one type of record, just the A and quad A. You can actually go back and query other types of records. I think we're getting a little ton of time, so you can probably try this one on your own time. The one that I would like to get to, this is one for where you can query the directly to the authoritative name server. So you can go and query through the regular hierarchy. So if you don't give any arguments, I just did a dig VicPiMakers.ca for A, it's going to traverse that regular DNS hierarchy, assuming I don't have a cached entry. However, if you already know what the authoritative name server is, you can just use give it the authoritative name server's name, and then you can get back the record directly. So this is a way to bypass that hierarchy if you have that information. And then this one, last one, would like people to give a try, because this is probably the most interesting one. And once people have given it a try, we can discuss it. This is dig and with a plus trace, and we're going to go for VicPiMakers.ca, and we'll look for the A record. So you want to give that a try. Once everybody says, everybody feels that they've at least seen the results, we can talk about them. Let's trace. I'll just right up here. I like this one. It's kind of meaty. So, does everybody had a chance to give this one a go?
Yep.
Is anybody stuck?
I'm good.
Okay, why don't we give it a try then? Let's see what it looks like. So you can see it's actually doing the recursive name query for us right now. It took a little bit of time. So this is an interesting fun query to go through. So you can see I ran this query for VicPiMakers.ca. You can see, I think if you count them out, there should be 13 root servers that are listed here. Those root servers, my recursive server, which is Cloudflare, will go out and talk to one of them, only one of them, and it's randomly. I don't know exactly what the algorithm, but it seems random. We'll choose. It chose jrootserver.net, and so jrootserver.net. What is it doing? It's looking at the root level for the top level domain name servers. So it says, okay, yeah, for .ca, because I'm looking at VicPiMakers.ca, I'm going to find all the CA records. Here they are. So it has the CA name server entries, the top level domain name server entries for those DNS servers. So the next step, it goes down here. It actually decided to choose the any out of that list. So any.ca-servers.ca. And in there, I find the authoritative name servers for VicPiMakers.ca. So I find two of them there. So I reach out to which one? I reach out to name server 2, cozyhost.space. And from there, I receive back all the, I've received back the A record, but I also hand back the name server records as well. And this is kind of some stuff that gets populated with your additional with the addition or additional response section. If you're wondering why you get additional responses, it's just there's a sort of a practice within DNS just to hand back more record, because those can be then cached by the recursive name server, and therefore it just makes it much faster for any queries that are going to come after the fact, after the initial, say, VicPiMakers.ca query. And there's a typical pattern that if you're querying for one of these records, then you're probably querying for more than one. So they just DNS just hands back a bunch of them at the same time. So that's it. Any questions about that trace using dig? No, that's all I have.
So I have a question on the
Me too.
Okay.
I was just having my stupid push to talk break. Go ahead, Craig.
My question is it the first recursive DNS server that's collecting all that information and shooting it back to the client, or how does this information that would normally be between the recursive DNS server and, say, the root servers or the top level, how does that get back to the client?
The recursive server collects the details and then it hands it back, and from that, it's been basically parked, and it will hand it back with that original A record request in this case to the client, right?
So it's the first recursive DNS server that's that's collecting all that information, then shooting it back to the client.
That's correct. Yeah, at least that's my understanding. So
How
the
much-
so you can see here that it's basically here it does 1, and you're assuming that you don't have a cached record. So it goes 2, 3, 4, 5, 6, 7, and then finally sends back 8. So it's basically been parked here. The request, that A record request, gets sent back after it's gone through this traversal.
Now, we've just seen what all this does. Does it do this all the time? I mean, just to find out stuff, or I mean, we basically asked for it to show us this stuff. But does it do all this and transfer all that kind of information every time it's doing?
No, that's the whole point of the TTL and the cache. So the DNS resolver is also, you can think of it typically, not always, but typically it will be a DNS cache as well. So it will cache the records there and hold them, and it holds them for the period of that time to live record. And
Okay.
once that time
doesn't happen all the time. It just happens as often as necessary.
That's right. So it waits. It will basically do it once, and it does. It's quite a bit of effort, obviously, for the librarian in our analogy to go through and do all that. So that's why it caches and just holds the record for a period of time. And actually, the authoritative name server is the one that's responsible for setting the time to live value, and if you have more volatile records, then you can actually set a lower time to live if you'd like, and that will mean that those records get cached out quicker. So
if I have 30 tabs open on a Chrome web browser, is the DNS resolver have all that information for all those tabs that are open, sort of cached there, and if so, how much memory does it take to have all of this stuff?
I'm not sure. I can't speak to the memory. It will, but you will be going out constantly to your DNS resolver to make requests, unless you have a local cache. And people can do this. You can set that up on your local. You can set that up on your local laptop, or you can set it up at your router level. Whatever level you choose, it's possible to cache at different levels.
Okay.
So it really depends on your own LAN and your own setup.
I suppose not in the browsers, they're normally caching all this stuff for you all the time, probably.
I'm not sure if the browser. I'm not aware of a browser caching that goes on. I'm not sure if anybody else is aware of that. I know that there are at the OS level, but I'm not sure at the browser level.
If the browsers did cache, it would probably be pretty annoying for most people.
Why is that, Mark?
The reason being is that you've got all these other things that are supposed to do the caching, like your local caching resolver on your host or on your DNS forwarder or your router or whatever is doing your forwarding and caching and recursion. That's where those should be done. If it's being stored in the browser as well, how do you clear your DNS cache in your browser? Do you follow? It could become annoying in the sense that if the records are changed and the browser's got it cached as well, where does it end?
Well, agreed. But a quick internet search says that Google Chrome does cache DNS entries.
Is that right? So it's curious. I'm curious to see how long they cache the records for.
Yeah.
It makes sense that they would maybe do it a little bit. I'd be really surprised if they did it for
They only
longer
cache
period.
the ones that go to Google.
Well, I mean, this stuff would be small. I mean, when you've got the cache contains the content of all those web pages, this is probably pretty minuscule in comparison to all the content, especially when there's probably images and all kinds of junk in there. It's in the browser cache.
Well, I suppose the browser caches it in the sense that it asks the operating system, what's the address for www.VicPiMakers.ca, gets that IP address as a 32-bit integer or a 60 or 128-bit v6 one, and then says, okay, I'm just going to hold on to this until I'm closed, and if I ever have to look up that address again, well, maybe I'll do it then. It might cache it in that sense, but I wouldn't think it would. Maybe it does. Anyways,
I have a question. So when you change your host or something for an IP, for a domain, they sometimes say this will take up to 24 hours to resolve. I mean, really?
That's
think-
the joy of caching.
Yeah, that's the time to live.
Yeah. that-
86,400 seconds is the usual. which
So
is
they will
24
keep their
hours.
cache and they won't refresh it for.
Well, they'll change the
day?
address in the database, but all of the systems in between who haven't been notified that it's been changed, like
Yep.
your caching resolver and
So what's a
recursive
reasonable
resolver.
expectation?
24 hours.
Really?
Yep.
That's
Yeah, because
like-
here, because at this level, you have control of the
time.
record. Well, you can get shorter TTLs, but the problem with that is that it means that it's beating up requests are beating up more on your authoritative name servers. So they don't necessarily like that because they already deal with a lot of traffic. So they kind of keep a standard of how the TTLs. Otherwise, you're just going to get a lot of extra traffic against your name servers. So
One thing you can do, George, is if you know you're going to be changing the IP address for a host within the next, say, 24 to 48 hours, you can artificially change the time to live for those records first and set it down to, say, 15 minutes, and then change it to in
I
24
do that
hours.
in my current host, and then before I change.
Yeah, you do it in your name server. So
Yeah,
that the time to live for the
Okay.
record you want to change is only going to be like something 15 minutes. And
Okay.
then so it'll
I
only
got
be
one other question.
delayed for 15 minutes for the most part. If you
We have
do it
this domain
24
name.
hours before.
Okay, thanks. We have this domain name bbc.org, which is really nice. I mean, geez, you don't get many 3-letter domain names that are like that. And we've kept it. And I currently have a page on Nearly Free Speech host, and it's their domain name servers that are recording it. And then I wanted to reuse this for Google's, what do they call that, service of where they take everybody's, they kind of reuse that domain name, but I'm not sure that it has taken effect. And because I can see that it's still handed by my Nearly Free Speech. What's that Google service like there? Oh, I don't know. They keep all their docs and all their stuff. Their schools use it. Businesses use it. Anybody know what I'm talking about?
Yeah, they've changed the name of it. I think it used to be Google Plus or something like that.
Yeah.
They've changed it to something else. I've forgotten what it is. I know it's
So they asked me to provide them with the name, with the domain name. So I gave them the domain name of bbc.org, but they never. But I don't see any change on. I didn't have to do any changes on the name servers for where we currently have that page. So how does that work? Should I document it a little better and send it up as a question later?
yeah, sure. We can. Why don't you maybe post it in Slack? Because I'm not really getting a picture of it right now. I'm not understanding the question.
And the last point I want to make is that this is a good technical discussion, but I think there is an important discussion to be had around your domain name and how to protect it, and especially for organizations. Because what sometimes happens is that the person who actually registers the domain name is the local webmaster guy that you got, and then he gets upset with the company and he walks, or he gets upset with the organization, typically nonprofit. He walks, and he never changed who was the
administrator. Yeah, the administrator.
And so what we've done at the Computer Club is we've actually got a password which is divided into 3 parts, and it takes 2 people to make a change on the domain name registrant if we wanted to change, repoint it, or do something like that. So there's a whole aspect of this that I think is important for nonprofit organizations and
Probably for companies too.
and for companies. I mean, if you don't control the domain name, you know, people invest in all, like bbc.org, you know, or bbc.co.uk. If they lose control of that because they got an upset employee, that's a real big problem, right?
Absolutely, yeah. That's your intellectual property. That could
Absolutely, it's your intellectual property, and it's become even more and more and more important.
I didn't include anything about that and sort of details about registrar. You're right. This is mostly a technical discussion.
Right.
I'd love to have that as well. I know. I don't think, Craig. I don't think you're talking about anything of that level, are you?
No, my stuff is lower down.
Yeah, it might be something for future discussion.
Well, I wrote a paper about it, and I'd be willing to share it, and we could see what people have to say about it. It's really about how to maintain all of the records of your organization so that no one person can walk away with the control of it.
Am I hearing a presentation, George? You want to do a presentation in September?
If it's, yeah, it could be in Netsig. I think it would be appropriate in Netsig, actually. The thing is that people who set up websites for other people really do need to pay attention to this aspect of what they're doing.
Yep, don't disagree. Okay, I'll put you down for September.
Okay.
Sounds good. So I'm done with everything that I wanted to discuss for this one. I'll be handing it off to Craig for the next one in August. And he's going to cover more on DNS configuration, DNS search lists, captive portals, DNS over HTTP, which I think is a hot topic now, and DNS for Soho. So I think there's going to be a lot of more interesting and more specific use cases that Craig will be covering next time.
Well, thank you for your presentation. Really appreciate it.
Yeah, thanks.
Yeah, it's good.
Thank you, Greg. That was really good.